Thanks, Jeremy. Good afternoon, everyone. My name's Matt Frater. I'm one of the senior devs on the Fairfax API team. And the application or the tool that I'd like to demonstrate for you today is the thing that we've constructed called Capisce, which could best be described as the content management system for Elasticsearch queries within the Fairfax Content API. That's a bit of a mouthful, but it's intended to solve a number of issues around application development and website development. And this is our implementation of what's been described as signed queries. Signed queries are literally and modifiable Elasticsearch queries that are pre-written and saved within Capisce and approved or in fact rejected by administrators such as myself or people in architecture like Jeremy. Probably the easiest way to demonstrate how it works is just to log in. Okay, now, Capisce is an absolutely brand new system, which is why there's only 2 queries in it, but hopefully this database will fill up fairly rapidly. And if I go into one of these records here, you can see that what I have is various attributes on this record. I have a name, which is really just a reference to what the query is and what it does. I have an API key, which is used for authentication further down the line in the API. I have a search index, which obviously is the index or indices that I wish to search against. And I have an asset type, which is literally an Elasticsearch asset type. And finally, I have the JSON that I wish to run against the index. Now, this JSON might be created by one of the Capisce administrators, or it might be directly written by one of the clients and submitted for approval. There's not much difference in terms of how they're managed. As you can see, this thing is pretty much standard Elasticsearch flavored JSON, with one slightly unusual exception, which is this thing here, this pattern, $. What that is runtime parameter substitution, which means that at runtime, I can change how the query behaves, what it's looking for, and so on, by just adding those runtime parameters. And the best way of demonstrating how that works is probably to just preview the query, which I can do if I'm an administrator, and it's detected that I have a runtime parameter called statebox, which in this case I'm just going to pre-fill with NSW for New South Wales. Preview that. There we go. And I get results back that match that query. So if I'm the administrator, I can judge the performance of that query. I can see what the data looks like. I can ensure that all the Elasticsearch shards are working, how many hits I get back, whether or not I really should be paging this information. All of that stuff I can manage from here. What, of course, happens when it's run against the API is a simple GET request against the API gateway endpoint, in which case, here we go, you have the UID, which is just the identifier for the query itself, the API key for authentication, and the runtime parameter. So if I was to say NSW, rerun that, what I get back is exactly the same bit of information. So that part of it actually works quite nicely. The other thing that we can do is that we can actually apply those runtime parameters to keys as well as values. So you can really modify on the fly the way that query works. Just to demonstrate that it is doing what I say, if I decide to change my asset type to venued, so I've mistyped it, I go preview, NSW. If I preview that, I'm not going to get any results back. I'll just get an empty data set, which is what I would expect. Obviously, if I try and search indices that don't exist, okay. Yeah, there you go. So any errors that turn up in the query are also previewable here without pushing them into the API, which is actually quite nice. So that actually works as I would expect it to work. Now, the other thing that I can do if I'm a Capisce administrator is I can approve or reject queries. For example, let's say the query we're just looking at, I've decided that it's not performant enough, it returns too much data, it needs modification, we can't allow application clients to be using it. I can reject that, and that rejection status is instantly reflected in what the API endpoint does. So all of a sudden, the query is not found. Luckily, of course, I can then revive it. Reviving doesn't bring it back to life, incidentally. It just brings it back to life within Capisce. If I refresh that, I'm still going to get query not found. In order for it to come back to life, I actually have to click approve. The status is updated, and my query is working again. So what we've done is we've really abstracted out all that complex logic, those large chunks of JSON and parameter substitution and all the various bits and pieces has all been taken out of the apps that are being developed to utilize all this data and put into Capisce and the associated APIs, which hopefully makes the apps smaller, lighter, easier to write, easier to reason about, to get approved, not to mention quicker and more reliable, and all the hefting is actually done within the bits and pieces that we've created, such as Capisce. It has other advantages, obviously, which is that the app doesn't need to use a whole bunch of memory and CPU cycles when putting its JSON together, because it doesn't put any JSON together at all. If it's an exceptionally complex query, as some of these things can turn out to be, it also means that you don't have to pollute your repo. It also means that you don't have to pollute the app's repo with a large amount of complex JSON or anything like that. And you're also not using up large chunks of internet bandwidth, shuttling big pieces of JSON back and forth. And that's really it in a nutshell.